Hello, y'all. Early Berry Jr. back again for some more, actually not some more physics, for some math, even though applicable to physics depending on what you're doing. A viewer earlier asked about multivariable calculus, so I'll do some of that. A welcome break, I would say, from all the more torturous stuff I've been doing in my actual degree to recall some things from the past. So let's see how this is sharing. Let me actually change the view. Let me actually make it a horizontal view, thinking about it. Let's see. Is that better? Potentially. Just have to resize the screen a bit. There you go. So let's see if this helps out with the view. Looks like everything is on the screen. All right, here we go. So the idea was about, let me change my text here. Awesome. Glad you enjoy. T variable calculus. So I'll do a simple problem where, well, I mean, you know what I'm saying? Now I'm sounding like those books that say trivial. You familiar with how complicated multivariable calculus problems can be? This is a relatively simple problem. I'll put it that way. And what we're going to do, I made this image earlier, is find out the area of, I guess I should say the volume of this space. See if I can calculate what the volume of this space is. So the idea is that we have the axes like so. So we have x, we have y, and v is going outward like that, away from us. Let's put it like that. This is v, this is negative z. And we have a parabola. We're going to make this too hard. Maybe I should just leave the z-axis out for now, because I can already see it's going to really mess the drawing up. We have a parabola in red. Y equals 2x squared. And then we have a line going like so. And the line is y equals negative 0.5x plus 1. And in the z-axis, it's going out, let's say, negative 5 is less than or equal to z is less than or equal to 5. So, in other words, we have this shape. Well, I thought to write it in purple to imagine that they're mixed up. There's no really easy way to draw this in 2 dimensions, but you can see what I'm doing there. And just imagine that. Yeah, I think I see how to do it. So if we're looking down, this is the parabola. it runs into the line right here, and then it becomes the parabola again here. So the line is cutting across, as we can see, and this will be the x-axis. The y-axis would be here in the middle, and therefore the z-axis would be like this, coming out here. So this will be plus z, this will be minus z, and this would be -5, and this would be 5. So hopefully it's clear the volume these lines are carving out in space. Right. It's 10 wide and is bounded by these things. So let's take a look and see. And hopefully I didn't make this too hard, but I think I should be able to do it. So first thing we want to do is find out where the lines meet. So first I'll get this area here. Awesome. Glad it's clear. So first I'll get the area there by finding out where the lines meet. And I'll find out where y is the same. Let me just do the whatchamacallit thing. So we'll say x equals -b plus minus square root 4ac b squared minus 4ac over 2a. You can say a equals 4, b equals 1, p equals -2. So we have -1 plus minus square root of 1 minus 4, 4, and -2, all over 2 times 4. So this means that for the left side, for x1 equals -0.85. So this point here, we'll try to pick a color that shows, is -0.85. Let me actually do this. So this is -0.85. And 1.42. Right, so that's where they meet right there. If you see what I'm doing, so I solved for the variables, the numbers, where they meet by making y equal. I found the x where they meet at. So now I know the y where the two equations meet at. Right. So this is x1, y1, x1, y1. And the same thing on the right side where they meet. Now I know where they meet over here. But this is important and vital, so I know what bounds to put for my integrals that are coming up. So let's figure out where they meet on the right side. So x2 equals 0.6. And in the calculator, I put it in exactly, but I'm rounding when I write it here. Again, y equals 2x squared. Y equals -0.5 x plus 1. So when I put those in, let me go back to the actual one. So 2 times should be the one there. Nope. Hit the wrong one. 2 times, that should be the 1 squared. So this gives me equals 0.7. Let's make that 0.7. And if I put the other one in, so it's negative 0.5, plug in the same thing, plus 1, and equals 0.7. Right, so now we're in business. Equals y, 2. So this is x2, y2. So this is 0.6 and 0.7, x2, y2. Right, so now we know where the lines meet. We know the bounds of the shapes. So now we can go to our integrals and we can figure out what this volume is. We have just enough time, almost at 9. So basically, this is going to be a triple integral, which is what the person was asking about earlier. We have x, y, z. And what we can do, I'll just call this f of x, y, z, and dx, dy, dz. This will give us the volume. So I want to make sure I do this properly. So the bounds of this thing, the lower bounds, is going to be 2x squared, and the upper bounds is going to be negative 0.5x plus 1. So really, what I can do is I can integrate over y and input what x is. So I should actually be able to do 0 y equals, so the lower bound is 2x squared, and the upper bound equals y equals negative 0.5 x plus 1, and we have that. We have v would be from negative 5 to 5, if I recall. And x, well, x does have a bound. X goes from that to that. So I'll do the x variable last. Actually, I'll do the x variable second. So we'll have something like this. X equals negative 0.85 to x equals 0.6. And dx, dy, dz. All right, so now we have our integral. And I guess f of x will be just 1, since we're just getting the volume of this bounded space. And if I recall, this should be good, right? So now we just take our integral. So I'll start with y. So we'll end up with integral x equals negative 0.85 to 0.6 y, and we're going from negative 0.5x plus 1 and 2x squared dx dz. So this equals integral x equals, oh, and I dropped one of my -5 to 5. So then we have x equals negative 0.85 to 0.6. Z equals -5 to 5. And now we have negative 0.5 x plus 1 minus 2x squared dx dz. So we have the area that's bounded by those two lines going from x to y. Let's simplify this. We have, well, good enough like that. I can actually just drop the parentheses to be simplification enough. So we have this. So then I will integrate by x. I don't think that matters so much, but I'll go ahead and integrate by x next. So we have integral -5 to 5 of negative 0.5 x squared over 2 plus x minus 2 x 3 over 3. And we're going from 0.6 to negative 0.85. We still have dz left. So we have -5 to 5. Let me put this in the calculator. So we have negative 0.5 divided by 2 times 0.6 squared plus 0.6 minus 2 third times 0.6 cubed. And then we have to subtract everything. So then it'll be minus the first thing, so that's plus 0.5. And anything is not clear, let me know. 0.5 times negative 0.85 squared divided by 2 minus, and it's a minus, because this is the second term, so you have the minus, so it's minus x. But I'm inserting a negative, so it's plus. So it's plus 0.85. And then we have minus, so again, that's a plus, because this is the second term I'm subtracting, 2 negative 0.85, or 2 over 3, times negative 0.85 cubed. All right. So we get out of that is 0.38 dz. So this would be the area of just this. The area right here is 0.38. Well, I didn't take units, but if this axis is in meters, then it'll be 0.3 meters is the area of this point, right? Which seems reasonable. You're going from negative 0.85 meters on the left to 0.6 meters on the right. So that range is what? 1.4 meters wide, but it's not the full 1.4 meters because you're cutting out some stuff. You're cutting out, so basically this length here is 1.4 meters, but you're cutting out a whole lot. I mean, you're cutting out, it looks like, I mean, just visually it looks like you're cutting out about half. Well, I guess it's a lot more than half. 6, 9, 12, 15. But this is showing 1/5 of the actual amount. So, seems reasonable. So about 1/5 is being cut out. You have all of this area cut out up here, all of this cut up here, depending on the slant. So, you know, I guess basically if we were to look at it with the box at the top, this area here would be the full thing. Like, take into account the entire area that we looked at. Can't see it clearly because it's at a slant. I would actually have to take the diagram and sort of make it a 2D thing, but I don't think it's necessary to take another screenshot of that. But all right, we shall go with that for now. So you have about what, over a third of a meter, not nearly a half of a meter, between a third and a half of a meter of area. And then all I have to do is multiply that by um, the length that we're working with. So that's going to be 0.38 z and 5, -5. So that's going to be 0.38, 5 plus 5. So it's going to be 3.8. Oh, hold up. Is that multiply? Yeah, let's multiply. 3.8 meters. So that means that the volume of this thing (3.8 meters cubed), because this adds something in meters, that adds something in meters, and the other one adds something in meters. All right. So that's generally the basic steps of that. Provided I didn't make any other algebra mistakes, something like that. I made up the problem before I started. But that's a general idea. So you figure out where the points meet, and those are going to end up being your bounds. You take the integral over all three axes, recognizing that you're bound for the x-axis, or at least the y-axis at least. The bounds for the y-axis will be these two. So it starts on the lower part of the y-axis with the bottom equation, the red one. The top of it is the top equation. And integrate over y, those are your bounds along y. Then integrate that over x, that gives you the area. Then integrate over z, and you have the volume, which is 3.8 meters cubed for this entire area, which I would say initially seems reasonable. All right, so I made up the problem, so not a good way to check, but I think you'll have the general idea. I'll go ahead and take a break, and I think I shall break for the night. So I've been studying like all day. But I will be back tomorrow, and I think I'll just chill, watch a movie or something. And thanks everybody who popped in throughout the day, who watched. I'll be back tomorrow with some more graduate level mechanics, or maybe something else if somebody brings up another topic. But I'll definitely finished working through the part of the book where I was at. And I want to make I didn't do bad on the last exam. Like I said, I made a B on the first exam. Uh, what was my grade? Let me see what the actual grade was. 82.5. I'm sure that's a B. Pretty sure that's a B. Let me check the syllabus and make sure. You should have welcome. Or it doesn't say here, but that seems like a B. 82.5. Yes. Let's see what the grade metric is by default. Hmm. What is it called again? Like if you have a 4.0 scale, GPA. That's right. So before I go, let me just check the GPA scale. See what's up. Oh, here we go. So 3. Well, still not giving me the. I do want the grade metric, even though I could convert it from that, but I don't feel like doing that. I'm gonna look one more place. I didn't realize they had A pluses here. Damn, it's pretty cool. All right. Do not see the scale, but I'm pretty sure that's a B. It seems like a B. But maybe one of my other classes has the actual scale in the syllabus. Over 70 is an A, you're saying? I guess that depends on which school. Pretty sure they don't do that here. I know some schools lower the metric so that grades are higher, but I'm pretty sure it's like more standard here. Yeah. So here, 80% is a B minus. At least at least for the class I'm a LA for, a TA for. 80% is a B minus and 83 is a B. So depending on the professors can change that. So if she has the standard one, then it's a B minus. If she adjusted it a bit, then it's a B. But either way it go, even if it's a B minus, I'm sure I could lift it up to a regular B. Let me see what my grade is for the whole class actually. That's just for the exam. So when I look at the whole class, because I know I did better on the homework, the whole class is a 86.25. Okay, so it is a B for the class, but it was a B minus for the exam. All right. That might even be a B plus. Is that a B plus? 86.25. Hold up. Let me go back to the syllabus. 86 point for what for the class I'm a TA for, assuming that's a standard one. Yeah, what was a B? Almost a B plus. It's like a half off from a B plus. Well, that's good. C is over 50. Yeah. Are you're in England, right? Or the UK? I guess that's how it is over there. In America, I mean, some of the places are doing that too. Like in the high schools, they're like, uh, you pretty much can't fail because, like, even if you just show up, you get like a 50 and like a pass is a 50. I don't know, but SMU I mean, I don't think they're super hard on the undergraduate physics people because they are most of the people here. It's not a physics school, even though they have a very strong physics department. They do a lot of good research. but it's not at the undergraduate level. At the graduate level, it's pretty intense. So, but it is a R1 organization, so they had to bring it like that. But awesome. I appreciate your comments. Thank you for showing up. Thanks to everybody else who popped in. If anybody else did, I'm sure I'll be back tomorrow at random times throughout the day. So make sure you have your little notification pinged, and I'll see you all tomorrow. Scientific, have a good one.